All right. Welcome, folks. Thanks again for joining us for another stream of the Machine Learning Community Stand-Up. I'm Luis. I am part of the Microsoft Docs team, and I work on ML.NET. Folks want to introduce yourselves?
Yeah, and I'm Bree. I'm on the .NET team, the PM for ML.NET.
And I'm Jake. I'm the dev lead for the ML.NET tooling.
Good morning, good afternoon. My name is Bart Czernicki. I am a principal technical architect for machine intelligence.
Awesome. Thanks for joining us, Bart. So today we're going to be talking about Blazor, specifically Blazor WebAssembly. With Bart, he took the time to come on and talk to us a little bit about that. We know that folks in the ML.NET community, they've been asking for this. I know I've been really excited about getting this working, and now that .NET 5 RC1 is out, it seems like this is finally a scenario that's going to be enabled. So we'll be talking a little bit more about that throughout the stream. But in the meantime, let's go into some community links and contributions. So to start off, there is this organization, PASS, which is sort of like a virtual user group. And unfortunately, this is right before our stand-up. So it happened literally, it probably just finished. And it was basically a workshop on introduction to ML.NET. So it's really great to see other organizations and user groups outside of this community stand-up sort of evangelizing and sort of promoting ML.NET. So this is great. We understand that there's going to be a recording of this. So whenever we get our hands on the link to that, we'll be sure to share with you folks. So stay tuned for that. We had Arafat here, who is an MVP, and he wrote this blog post talking about beyond sentiment analysis and how you can use object detection with ML.NET. For folks who may not be familiar, the object detection scenario with Model Builder, at least training object detection models with Model Builder, leveraging Azure Machine Learning, was released in the previous release, right? So you folks can go ahead and give this a try. If you download the latest version of Model Builder, you can train your own custom object detection models, right? So he basically just goes into how you might want to go about, basically training an object detection model in Model Builder and walks you through the process. So this is really nice. And if you folks, take a look at this, you can sort of follow along yourselves and train your own custom object detection models. Speaking of object detection, or just in general, different methods of training with Model Builder, we have Bruno again, who was kind enough to put Model Builder through the ringer and essentially use different methods of training models, whether that's just using the CPU, the GPU, and using the Azure, right? So if you want to train in the cloud, and he basically just documents his experience here training different types of models on these different environments, right? So make sure to check that out. Again, for folks who are Portuguese-speaking audience, Davi Ramos put together this blog post, which is basically talking about models, how you can deploy models in production via Web API using Docker. So he basically takes you through what the process is of containerizing an application or a web API that would expose your ML.NET models via Docker. Now, if Docker is not particularly the method of deployment that you're really interested in, or maybe you have a different scenario that is more event-driven, Praveen put together this really nice guide that talks about end-to-end serverless deep neural networks and how you can deploy them with Azure Functions. And again, it's going to be using ML.NET to basically deploy to Azure Functions. So again, you have those both scenarios, whether you want to deploy to Docker or whether you want to deploy to Azure Functions or some sort of serverless environment. You can basically leverage whichever one of those best fits you. This week is Ignite, and hopefully you folks have been following along. There's been a lot of really interesting announcements, and one of them is actually related to what we'll be talking about today. And it's basically now you're able to use Azure Static Web Apps with .NET and Blazor. So before, right, so Static Web Apps, if you are not aware, is this service that you can basically use Azure storage to put your files, right? So if you have a static site, like a Blazor WebAssembly website or application, you can basically just put your files in Azure storage and expose them as a website, as a static website through Azure Static Web Apps. Now, prior to this, my understanding is that you could only deploy the static files, right? And with the new update, what you're going to be able to do is sort of similar to if folks are familiar with the Jamstack, right? JavaScript APIs and Markdown for generating basically static websites. This is a similar use case, except now you're going to be using full sort of .NET Azure Functions type of stack, right? So it's really nice that this scenario is enabled. So now not only are you deploying the static assets of your website or application, but you're also deploying the APIs along with your backend that you're going to need all in one package. So that's pretty nice. Talking about deployments and basically operationalizing those deployments, Alexander here did a talk. I believe it was at a user group on MLOps, a tool that he's been working on and he continues to work on. And if you're interested in checking it out, learning a little bit more about machine learning operations or MLOps, feel free to check this out. Now, Bart's going to be talking a little bit more about this, but I thought it was really nice in terms of helping you conceptualize some of the applications that Bart has built. And this in the architecture center here of docs.microsoft.com, you're going to be able to find one of the applications that Bart has put together, leveraging ML.NET and Blazor. In this case, it's Blazor Server. But you can imagine that now that the Blazor WASM scenario is available, you can potentially re-architect that in a way that suits that scenario. So that's it in terms of community contributions. But if we move on to what's new within ML.NET, one of the nice things that just happened was ML.NET 1.5.2 was released, right? So a few days ago. And for 1.5.1, it introduced a regression that has since been fixed in 1.5.2. So if you folks haven't upgraded to 1.5.1, we highly encourage to just skip 1.5.1 and just move to 1.5.2. That being said, in addition to fixing this regression, it introduced a few bug fixes as well as some additional support for Onyx types. So make sure to check that out, 1.5.2. And last week, or not last week, but on the last stream, we had the folks from the C# team come on and talk to us a little bit about TensorFlow.net and the different projects that they're working on. And TensorFlow.net actually recently released an upgrade to the newest version of TensorFlow. So currently there's some investigation and some work being done on how ML.NET can leverage this sort of upgrade of TensorFlow.net to basically improve and upgrade ML.NET. So, yep, that's that. Now, with that, let's turn over to Bart and his demos.
Awesome. Thank you, Louis. That's lots of cool activity there on the community stuff. It's pretty impressive. Can you guys hear me okay?
Yep.
Sweet. Okay. So what I figured, thank you for the introduction around the workbench. And I figured what I could do is kind of why I'm so excited about Blazor and WebAssembly specifically. I'm a old Silverlight developer. So, 2009, 2010, I wrote a couple books about Silverlight and business intelligence and how you can do analytics and advanced analytics on the client. And if you remember, Silverlight had, was able to do some of these things run on the phone, run the browser, but it required a plugin framework. And, because of the different tech stacks that have emerged in some of the technologies, Silverlight and Flash kind of went their own way. And what's really exciting about this now with Blazor WebAssembly is that you can bring some of those patterns back and offload essentially compute down into the local edge, being the browser. And what's really interesting about what we're going to cover today is now we can do, before you could do some compute, you can do some basic applications, but now you can do probabilistic programming leveraging machine learning.net. And that is what we're going to be talking about with .NET 5, RC1, which I'm going to be showing, as well as machine learning.net and Blazor technologies. So that's what's super interesting. A little bit about my background in addition to the machine learning I do at Microsoft. So what I figured to do is I'll do a quick demo maybe of what is available now. If you're in .NET Core 3x or .NET 5, if you follow this link, akms/baseball workbench, and you want to play along and follow along as I kind of demo some of this stuff, this is what we're looking at right now. So let me maybe make this a little better. This link here. So if you follow this link, you'll be taken into this application here, which Louis was showing the architecture of. And basically, this is a hosted application using ASP.NET Core on using our Azure App Service. And this is using Blazor server-side technology and is embedding machine learning .NET models inside in memory here. So what you can do here is, I have a quick demo. I'm not going to spend too much time on this one, but I wanted to kind of give a lay of the land of what's available now. This is using historical baseball data for the last 140 plus years and doing a classification of baseball players' careers, whether they made the Hall of Fame or could be introduced into the ballot. So basically, if you're inducted to the Hall of Fame, or the probability of being on the ballot itself. So you can pick your favorite player here. You can search Pete Rose, for example. Had a very, very great career. You can see his Hall of Fame probability and on the ballot probability are very high. And you can do very quick what-if analysis around what is happening, what his career could have looked like if he played less years, or what his career could have looked like if he played more years. And what's really interesting about this is that this feels like a client-side application. It's very, very responsive. ML.NET is doing inference on the server in real time, but it's pushing down that inference down using SignalR or WebSocket connectivity. So there is a server component that is required here. And in .NET 5, what has happened is the Blazor technology has, and especially on the WebAssembly side, has moved over from the mono runtime to including the base class the core libraries are now based on .NET Standard. So what this has allowed some compatibility to be exploited using the compatibility that ML.NET is written on, and now is more in sync with the compatibility with Blazor WebAssembly. So Blazor WebAssembly is a little different than server side, where the entire compute and execution is done for you on the client side. So whereas this compute, as I move each tick over and each probability is changing in real time, this is done on the server, and this is pushed down to the client, to the web browser here in Chrome. And what Blazor WebAssembly allows you to do now is basically mimic this, but now the compute is completely done on the client. So there's no server requirements that have to be processed. And so now you can do the full execution, the rendering, the JavaScript DOM interoperability, as well as the machine learning models can be loaded in memory on the browser, and they can be executed and inferred directly on the browser and on the edge. So you can have complete offline applications without having to make API calls, WebSocket connections, calling into Azure functions, calling into remote storage. It could be all pushed down to the local client. So what I'm gonna do is maybe show a demo of the client application and show how it works, and then go over the architectures and the code as well.
So before you get into that, Bart, just wanted to ask, so you were mentioning that you're pushing everything down into the client. So what you're saying there is, as opposed to sort of the link that I showed of deploying to Azure Static websites, you're saying because it's all static assets, you really don't need connectivity to any sort of server. You can just bring everything down and even use it in offline scenarios. Is that right?
Exactly right. Exactly right. Because of those scenarios, the entire application, it can be cached locally. And I'm going to cover a neat little feature that you get in Blazor WebAssembly called PWA, which is Progressive Web Applications. And that allows you to essentially make the application look and feel almost like if it's a mobile application, like an Android or an iPhone application to a client. And I'll actually show a quick demo when we show this, that you can actually turn off offline mode, and you can see there's actually kills all the traffic between the browser tab and the network, and you can see that the full application will still continue to run.
Very cool.
So moving on, this is available now, and Louis has mentioned there's links out there. If you go here, there's info resources. I'm not going to spend too much time here. If you want to build this application, the architecture, the documentation, the source code, there's Docker containers I have available here. So if you want to immerse yourself into this server-side technology, feel free to do so. And just to be clear, this is what's available currently in .NET Core and in the LTL release, and this is what's available obviously Blazor Server continues to be supported and a first-class product functionality in .NET 5 as well. So now we're going to move on to a demo in here called prediction inference test Blazor WASM. So if you're following along below, this is going to be right here. So ML net and Blazor.AzureEdge.net. And as Luis was mentioning earlier, this is actually hitting the Azure Static website. So we're going to be doing, I'm going to be walking through a demo that is Blazor WebAssembly with .NET 5 RC1 with machine learning.net deployed to an Azure Static website. So there is no server anymore. Now this endpoint here is essentially a CDN endpoint that is pointing to a static set of files, pointing to a cloud location. So a lot of links here, so feel free to peruse on as you will. Source code, demos, additional related demos are all available here. Different ways of deploying it, static website, app service. So I have demo links and source code available so you can see the different nuances and how the different things work. So what's actually interesting here, what I'm going to do is actually click this link here, probability test. And this probability test actually goes in and loads 30,000 rows into memory dynamically from a CSV file. So if you're a data scientist or you've worked with Excel notebooks or Jupyter notebooks, R, Python, you're probably familiar with loading data from a CSV. So exactly what we're doing here. And what's actually also happening is I'm actually loading several different algorithms and models that have been built. So these are models that have been built with these specific algorithms. You can think of them as experts. As a end user, you can think of it as going to a doctor and getting opinion 1 or opinion 2, opinion 3, and seeing how these different experts disagree or agree. And if you're a .NET developer, you think of these as data structures. So data scientists operate on algorithms and models. If you're a .NET developer, you're operating on data structures. Hash tables, linked lists, arrays. There's differences between them. They take in data, they do something with the data, and expose that to into your software. Same thing here. We have these different scary-looking names. Fast vars, fast trees, generalized additive models. But essentially, what these are data scientist data structures that do something with the data, do something interesting with it, and expose some functionality with it. Now, with the functionality, what a model does is, in this case, is a classifier. So it basically classifies the career of Mike Trout, in this case, into yes or no. This person can be on the ballot or not on the ballot. In addition to, some of these algorithms also support the exposing of probabilities. So you get this number. So it can tell you how certain I am that Mike Trout is going to be on in the Hall of Fame. Not just saying he will be or not saying he won't be, but also maybe in combination we are really sure, or we're really uncertain that he might be. So let's take a look at that real quickly. So if I click on any of these different algorithms, I'm loading a model and doing the probabilities in real time. Basically, if Mike Trout's going to be on the ballot or also inducted into the Hall of Fame. In addition to, I'm also rendering a nice looking chart here. You can zoom in a little bit. And this is all using SVG, Scalable Vector Graphics, and basically plotting every single one of these algorithm outputs, these probabilities for every single one of these algorithms, whether the person, Mike Trout, made the Hall of Fame ballot or is inducted, as well as I'm drawing the line through the different probabilities of the outputs. So for example, let's walk through this. So Mike Trout has played 9 years. For every single of the 9 years, I get a probability for the model selected, as well as the ancillary models. And basically I draw a line through the probability. So year 2, probability was less than 10%. Probability of 7 for making being on the ballot was around 78%. Conversely, being inducted to Hall of Fame year 7 was around 30% for these different type of models. And I have a range chart that defines the realistic range of the probabilities for the different models. Now, what's really interesting here is that this is completely done in the client. This is all, you can see how quick this application performs. It's very responsive. And the best part is this is doing, every single one of these data points that you're seeing, every single point on this chart, every single line point, every single one of these items in the table is 100% generated in real time using machine learning.net dynamically. There's no caching here. There's not cheating. I'm not cheating where loading everything into memory and giving it all probabilities and just kind of reading from a table or loading from the CSV file itself. This is dynamically, as I click each different player and you just play with it yourself, this all works, and it works pretty quickly. Now, going back to Luis's point earlier, if I hit inspect here, and I hit network, and I hit offline, so I'm going to take my entire browser offline now. So if I go back here and go back to probability test, and I continue working with this, you can see the application continues running. There is zero network bandwidth going back and forth. This is entirely pushed down onto the WebAssembly virtual machine inside the browser, and inside that virtual machine is what Blazor WebAssembly is executing inside. And this is all .NET, machine learning.net, and what's it called, and the data itself that's actually loaded in memory. So this is really neat. And as you can see, the application is responsive. It can run in, if it's fluent, so it actually works on the phone. I actually have my two phones here, my iPhone 8, my iPhone 6. So my iPhone 6 from 2014, which is what, 6 years now? The iPhone 6 from 6 years now can still run this application and run it pretty okay. And obviously iPhone 8 does better with it. You can feel free to check it out. You can actually see the application running pretty smoothly and runs pretty nicely. So let me actually take a step back here and load this application in Edge, and I'll show you why I'm doing that in a second. So I'm going to load this application in Edge, and I'm going to show you another really nice feature of this. Not only can you run everything on the client, you can actually, because these applications look and feel like essentially local applications. The idea here is why not take the next step? Why not just show looking at it on the browser, but try to make it feel more as if it's running locally inside the OS. If you're browsing on an iPhone using Safari, or you're using Chromium-based browser, so basically Chrome or Edge, you will get this nice little link here that says install app. So actually, I can now take this application that's been running inside 100% on the local Edge and actually install it. So let's hit install, and this application now is running. You can see what happened. This actually is the progressive web app extension that is available in Blazor WebAssembly. So this took the entire application, cached it locally inside, and still using browser, but it removed the toolbar and removed the kind of look and feel of a browser. Kind of looks and feel like a standalone application. It still is responsive, still works completely offline. If I disable my Wi-Fi, which I won't, it would still work. And this actually looks and feels like a fat client application that I'm running. And it's running machine learning.net completely locally. All the models are running locally here. And then what's also cool is you can see I'm on a Mac, so I'm cross-browser. So this is, as you mentioned, machine learning.net and .NET 5 cross-platform, cross-browser, support different tooling across the different ecosystems. I get this link here. I can actually drag and drop this link and install the application down on my taskbar. So I actually have done this earlier because this little M here. I'm gonna click it, and I'm launching the application as if it was a fat client application. This is completely running inside, still running inside the WebAssembly virtual machine, but it is running. It looks and feels like a fat client application, and does not look and feel like it's a browser application. It kind of stripped out that component out of it.
So let me ask you really quickly. So this is all really awesome, by the way, and this is truly the scenario, right? That customers can enable when doing when basically leveraging Blazor WebAssembly and WebAssembly in general. But I'm thinking, how much work is it for me to enable this, right? Or is it really easy? Like, what's the effort like?
Yeah, and it is literally checkbox. to get this experience, this PWA experience, it is literally when you do new project and you select the Blazor WebAssembly template. There you're gonna have a checkbox in there where it says enable PWA, progressive web apps, and you just check it. And we actually bring down, and then inside the template, we actually enable the manifest and the service worker, which actually, and then some icons, so that you can change. And basically that manifest file, that service worker, and the icons, those three components together enable the ability to make this a progressive web app and turn a regular Blazor application into a progressive web app application. So literally a checkbox, or if you wanted to, you can manually just copy, I think it's 4 or 5 files and reference them, and then you're ready to go. So this experience is almost out of the box, if you will, inside the tooling of Visual Studio.
Very cool. So we have actually a few questions here in the chat. Sure. One kind of going back to, I guess, all the components that you're showing, the graphs and I guess the tables, maybe. I'm not sure, Curious Drive, if you want to clarify that, please do so in the chat. But the question is, are these components part of? And I'm going to guess what's sort of blurred out there is ML.NET. Is that right, Curious Drive? So are these components part of ML.NET?
So these components here, this is what's the beauty of using something like Blazor. Basically, it's all HTML and JavaScript here. So this is just HTML and CSS. That's all this is. We do have partners that actually provide components out of the box. So there's, I think, 4 or 5 components that if you go into the Blazor site, I don't want to start listing them because I might miss one, and I would feel want to leave anybody out. But there's we have partners that actually can provide components out here. This demo is using straight up vanilla HTML and CSS to make it look nice and pretty, styled, if you will. But we do have if you want to make an easier button where you want to drag and drop or put a control on our table or button, and you just want to bind it to a data set or bind it to an action, we have partners that do that as well. Very
cool. And then another question that we have is, if you're bringing all of this locally, how large is the whole package in the browser?
Yeah, that's a great question. Yeah, that's a great question. So if you look at it completely all up, let me see if I can. The entire package is 16.5 megabytes. Now, 16.5 megabytes might sound like a lot, but that includes a few things. That includes every single one of the assemblies that's referenced here. It also includes the entire full .NET dependent framework, and also includes my code. So it includes all those 3 things down to 16.5 megabytes. And this also includes my data, my models, and everything else, right? So this is the complete application. And if you can actually see how quickly it loads. It sounds like a lot, but you can actually see how quickly it loads by clearing out and hitting the edge again. Obviously, these are the Blazor team and .NET 5 team is working to make these smaller. So these will not only get smaller but more compressed and more efficient. So this application, the specific application, is 16.5. But I'm obviously loading a bunch of data. I have I think a couple dozen models in here. I also have SVG. I have the JavaScript references. So I'm probably not the best application to gauge the size of what Blazor is, because Blazor applications can be much smaller. I'm just referencing a lot of additional stuff that probably doesn't need to be referenced in a traditional smaller application.
Yeah, and Curious Drive actually points something out here, which is this 60 megabytes are only a one-time download. Once it's local, exactly right? It's there, right? It doesn't matter how many times.
Exactly right. So yeah. Blazor WebAssembly, what's really nice is that service worker that I talked about essentially is a JavaScript file. It basically, each time you load a Blazor web application in a progressive web app manner, it reaches out into the server and goes, hey, what's changed? What's different? And then it actually brings it down. And actually, when I was preparing for the demos today, I actually had everything deployed into my Azure CDN edges. I had everything. I had these applications installed and severed from computers just as backups, just in case something goes boom. And I pushed out an update, and I clicked this, relaunched this, and actually what PWA was able to do is reach out to the server, find out what's different, and bring down only the delta. And I didn't have to reinstall the application or wait a long time. It figured that all kind of like automatically figured all that stuff out. Just I think pretty neat.
Very cool. Very cool. And I guess, if it's all right with you, maybe we can take one more question related to getting everything locally.
Absolutely.
And this is actually a really good question, One-Time Poker. Are there security issues when it comes to dumping the code on the client?
Yep. Yeah. Basically, all those rules apply. I mean, I won't take too much to answer the question, but anything, if you think about if you're writing a phone application, right? Is it an application like where, you want to, have a light footprint on the UI and basically call a bunch of services through APIs, and because there's some security or regulations and or some IP that you don't want out there. In those certain cases, you would not do this. However, if there is anything non really bringing down machine learning models and anything local, you're taking a risk. You're taking a risk of putting your code down on there. And there's ways, obviously, to mitigate that. There's obfuscation techniques. Obviously, our partners that, as mentioned earlier, that bring down their IP and their charting their charting work and things like that. There's ways to mitigate that, and then we have those have been around for a while. They still exist in Blazor, but obviously that's a kind of like a middle of the road kind of answer. So things, if you want super security and you don't want things on there because you don't want things to get for example, you wouldn't put a password generator down to the client, right? That'd be kind of silly, right? Because that you're just asking for somebody to somebody hack you, right? That you would never do that on the client, no matter what. Even if it was encrypted and super secure. So, and then obviously we have those mechanisms inside .NET which allow you to obfuscate the code and have security concerns and being able to pass down licenses. And obviously the other opposite way is when there's nothing very specific or you're not worried about your IP or security wise, then you obviously have more freedom to do and bring down these objects down locally. So not a great answer, but I know it depends. And you can actually see some of that in action if you download some of our partners and you go, new Blazor WASM application, download one of the charting packages or data visualization packages for our partners. You can see some of those security mechanisms in action. Actually, you'll fire it up and go, wait, why is this license thing popping up? Why is this key? Oh, let me look at their code and see if I can, fire up LDASM and try to get in there. You can't, right? So there's definitely techniques to secure your code and make it safe. So, and same things where if you're doing a React application, Angular application, those same security patterns, best practices apply here. No different.
Right, and just to kind of extend the definition here of code, right? You should definitely treat your models as if they were code, because
Absolutely.
Those two are coming down as static assets, and because people can expect them, you should be treating those just like you would the rest of your code.
Yep, great point. Exactly. So I can show maybe a couple of architecture documents and walk through some code just to see if that's okay.
Let's do it.
All right. So this is on my GitHub. So this presentation, I'm not going to walk through the slides, but if you're interested, you can kind of see more details of how this was built and more information. This is the, make this a little bigger maybe. This is what the workbench looked like deployed into Azure App Service. So you have my mobile application, web browser, if you're following along. You hit it, you made a WebSocket connection via SignalR, and basically, there's instrumentation and things like that, but this ran on a server. This is running on the server, pushing down communication through SignalR. You can see Blazor and ML.NET, they're running in memory, and the machine learning models themselves and the data decision analysis all is running inside the server. It figures out what the probabilities are, it figures out what to do with the data, it figures out how to make the card, different colors. It renders the delta of the HTML, pushes it down, and tells the Blazor runtime via JavaScript to say, hey, this is what your state was, this is what it looks like now, and it makes it look pretty, basically. That's what the Blazor server side looks like with machine learning. So what does it look like with WebAssembly? So now with WebAssembly, we're introducing a couple things. We're introducing the different deployment option using deploying into WebAssembly and runtime. as well as .NET 5, and we're hosting on a static site, not a dynamic site. So now there's no compute on the static site. Now, how does this look like on a WASM option? Same thing. You have a mobile web browser. You have network local communication. So obviously, initially it could be network. It could be completely local if you have a PWA or you have an application fully cached. It is actually using the WebAssembly virtual machine inside the browser, and is doing the entire execution of code, framework, machine learning models, your prediction analysis, running the Blazor interop between SVG and JavaScript, and everything is inside the web browser. So everything here, there's no, in this scenario, in this specific example, there is no callbacks to an API. There's no server. There is all the compute is 100% inside your local web browser. And what this makes, for cost purposes, this is a fraction of any cost. A static website deployment like this is roughly about $2 a month. The cheapest version that we have on app service, if you did this, would be about $10, and realistically, you probably want to go at $40, $50. So you can see that you're talking about, at least a 5x to even higher savings by deploying your application as a static site. Now we say static. Now we're using the term, that's a Microsoft term, Azure Static Websites, Azure Static Web Apps. But we obviously have free options. You can potentially do this using GitHub Pages. GitHub Pages has static websites. Now imagine being able to have a static website that, in a term is static, but essentially has dynamic components into it by basically being able to do machine learning live. So, if you're a data scientist and you're familiar with Jupyter notebooks, Jupyter notebooks are nice. You have some text, you have code, you have outputs, you have visualizations, but they're largely static. You need to fire up Jupyter server, put it somewhere where Jupyter can run the compute, whether that's local or on a server. But you need some kind of you need that server component to run in order to make it dynamic. What's really nice about ML.NET and Blazor WASM is now you can actually have these documentation sites or simulation sites or interactive kind of small information portals. Like New York Times does a great job. Once in a while, you go to New York Times and they have an interactive site, and it's all you can play with the data, you can and see how it works. But it is a news article, but it's interactive. Blazor and ML.NET now can facilitate that and dramatically lower the costs here. One more thing to touch on a little bit here, because I think there was a question earlier how I'm doing the rendering of everything. All HTML, Java, and CSS for the look and feel, and the graphics are done by D3, JS, and SVG. So after Blazor is done processing the machine learning models, the predictions, the outputs, and running with the data, and I'm ready to render, I do a fire and forget method inside Blazor and call in D3, JS, and render the application so it looks aesthetically pleasing. So this way, it's and SVG is obviously super fast, runs on mobile, lightweight. Super popular data visualization framework, and it's perfect for something like machine learning.net, where you want to have a little bit more power on how your visuals look like. So that's kind of the difference between what was available now in .NET Core 3x with Blazor Server and .NET 5. Blazor Server obviously works in .NET 5 as well, and what's available now, and how you can potentially approach this problem in .NET 5 RC1. Basically, you can now take your code, and I could literally copy and paste the code from here, from my previous application, put it in here, make sure there's no, obviously no signal R references and things like that. But I literally, this would be a great majority would be copying and pasting code. And I can have my Blazor server application actually running inside a WebAssembly. And I actually have a couple of different demonstrations and links in the presentation here and in the GitHub where I actually show .NET hosted, non.NET hosted. And it's literally, if you look at the code, it's the same JavaScript, the same CSS, same HTML, same C# with a few tweaks. It's almost identical. What you can do now. So I think this is pretty neat. Maybe I'll talk about some of the gotchas. This is slide 7 in my presentation. And this is some of the checklists and making sure what you have. Obviously, .NET 5 is in release candidate, so it is. It's not general availability yet. I think it goes GA in a couple months. I think in November is the timeframe when we go live. But obviously we're in release candidate, so you do need, in order to replicate this yourselves, you do need the release candidate builds. I'm using ML.NET 1.52, but I tested it with the previous versions and it works fine. So some kind of semi-recent version of ML.NET, I'm not sure what it is, but semi-recent. If you have the Visual Studio 2019, the tooling is included in 16.8 Preview 3. So you do need the Preview 3 tooling from, I think, September 15th was the release for the tooling for Visual Studio 2019 that supports .NET 5 RC1 and has all the integrations with NuGet and Blazor WASM and things like that. And the big thing here is and I'll go through the code in a second, is basically you need to put the ML.NET NuGet packages in a shared library and reference them inside the project. And that's kind of a minor workaround for some kind of for a CPU warning directive that you get that prevents kind of a clean build. And that's something that hopefully will be fixed soon. But basically, when you create an application, file in Blazor WASM, don't add your ML.NET assemblies directly into the application. Create a shared assembly, put them in there, and then reference it. And I'll show you how that kind of looks like. Currently, ML.NET inference works in .NET 5 Blazor. So training AutoML is currently not supported yet, but you can take your models that have been pre-built, however you built them, and put them, and you can now take them and do inference on. So basically, inference is being able to now take a model, not training it, but being able to take an existing model and then passing new data and getting prediction results out. Static websites and ASP.NET hosted deployment is supported here. As you saw the demos, it works fine with ML.NET, and also PWA's offline caching works with ML.NET as well. So that's those two techniques here that Luis was mentioning, and as I demoed as well, are fully supported. And for a Blazor server, the gotchas here are basically if you want a completely offline application, if you want static website deployment, that is not, you don't want to do Blazor server. But that's Blazor WebAssembly, where you want to kind of reduce costs dramatically and basically deploy to a static website. So Blazor WebAssembly technology here, the list of items to kind of be wary of until we go into GA in a couple months, where this list will hopefully be completely mitigated, and what's available in server and currently as well.
And maybe something to add on to the Blazor server is that the PWA scenario is also possible, right? But the difference is you're still dependent on that server. Is that correct?
Exactly right. So it's not completely offline. You're still going to be communicating back and forth. Right. Exactly right.
Yep.
So it's kind of it does give you some of the benefits of a PWA. It gives you the benefit of the application look and feel like it's installed. It's not running inside the browser. There's caching. So if an application is large, it can be pre-cached, and also when you launch it for the next time, it's pretty quick, pretty responsive. So there's no install, if you will. There's no waiting. So yeah, you do get some benefits of the of a server side Blazor, but you still don't get the full complete offline capabilities if you want the application to be completely offline. It's actually interesting because one of the patterns I actually used, this is 10 years ago from Silverlight, when I used to bring down historical baseball data, and I actually would take the individual assemblies and I chunk the assemblies back into different years, and I would have 150 assemblies for each year of data. And as the user was dynamically bringing them in, you could dynamically download them and bring the assemblies down into the client. So very cool patterns that you can do right now, that you can actually have a massive amount of data just available sitting on there on a static website and just waiting for you to consume. And as the user is using it, basically being able to virtually hot load it down to the client. And I think those patterns are just super cool, right? And that you bring down and things like that. So yeah, absolutely. So mix and match, hybrid, completely offline, or I love WASM, but I want to call it a function, right? You can do it that way too. So a few different ways to kind of approach it. And let me show you, maybe I'm running out of time a little bit, but let me show you how this kind of looks like in code. So if you download my code, this is, we're cross-platform. So I'm using Visual Studio for Mac. So this is, on the Mac, full Visual Studio, fully supported. I can build this, and it's what can run. I have my Blazor WASM host assembly and my .shared assembly. So as mentioned, that is where, make this a little bigger. This is where my NuGet package goes. So this is where my Microsoft.ml, my FastTree, my LightGBM, any other related Microsoft ML packages, they would go inside the shared assembly. Inside my main Blazor application, I do not have Microsoft ML reference. If I reference Microsoft ML, it will actually give me a warning. It'll prevent the build and things like that unless you do some workarounds, but keeping it simple, this is a nice way to put your ML.NET assemblies inside the standalone application, .shared, reference it, and then and reference it here, and then basically you get the goodness of all the Microsoft ML stuff passed through implicitly into your host application. And if I look at my code here, if I look at for example, pages, probability test. And you can see, I am using, I can perform predictions. I'm using calling essentially Microsoft ML through the different methods here, and that's the way to kind of work around the current limitation of not being able to directly reference Microsoft ML directly inside the Blazor application.
But in part, it's kind of nice, right? Because you get to sort of decouple both of those things, and your machine learning components get to change and be updated independently of your Blazor and web application.
Absolutely, and it's actually funny you say that because if you go onto my GitHub, when I have a hosted version and a non-hosted version, I actually just literally take the shared portable. I'll call it. I'm not using the right word here, but taking that assembly and basically link it to another project. So I can take this and link it to completely somewhere else, and it just works. It honestly should be a best practice. But if you do file a new project out of the box, you just get one CS project, and then you initially start going, okay, let me add machine learning.net in there. Whereas if you add the second assembly, if you start thinking about building a bigger application, this is where that happens. But absolutely, you're right. That's a standard best practice. You would want to do this anyway. But if you're doing a kind of hacking up a demo, you might run into that issue. Couple of notes here, so you can see how is this brought in. Basically, I take this and inside the project, I have a reference. So I'm just adding reference. So no big deal here, right? Adding reference. And the one other thing you need to do inside here is in the imports.razor. Basically, what this does is you can think of imports.razor as where all my using statements are kind of going. That are kind of shared across all the different pages and components inside Blazor. And you can see right here, I added Microsoft.ml. And then without even having a reference directly in a project, that implicit reference through that shared assembly allows me to actually directly reference Microsoft.ml inside here. So that's the kind of like the workaround that you might run into. But otherwise, I think you asked the question earlier, how easy is it to get started? I answered the question from the PWA perspective, but from adding ML.NET, that's it. New project, Blazor WebAssembly, create a shared assembly, put your Microsoft ML.NET in there. Find some of the great community examples that we have out there, and just copy and paste the code, and it will work. Inference stuff. Should give you a positive result there. And obviously I have my examples here, and I'm sure there's going to be others coming because just a pretty cool scenario. So you'll be able to pretty quickly work with that. I did want to mention maybe a couple things here. Or is this okay? This is where the JavaScript. This is where the rendering of the chart happens. So this is basically a fire and forget, where after everything is done on the machine learning side, it gives me all probabilities. I'm ready to render. I'm calling out to d3.js via Blazor WASM. So basically anything you can do in JavaScript, you can extend that out there. So if you already have a great, fantastic code that you have in Angular or React or JavaScript that you're happy with the user interface, that's great. You can bring in Blazor WebAssembly and machine learning.net and extend your application and fuse it further. I already have an investment in JavaScript. I already already have an investment. I don't want to rewrite everything in Blazor or in C#. You don't have to. This is the way I would start a new application. But if you already have an existing investment, you can attach essentially a new Blazor WebAssembly component and interact with JavaScript. Call JavaScript to Blazor, or from Blazor call into JavaScript. So that's really cool, right? So now you can have a JavaScript application that you already have, add a Blazor component, and call into machine learning inference methods, right? So your ML.NET models can now be do inference using JavaScript. So
yeah, that's really a really cool call out, because you know, some people tend to think like, oh, Blazor, so I never have to write JavaScript again, and that might be true. Right. It may be true that you can do away with a lot of your JavaScript, but it's not an either or. It's more like an and type scenario, where you use JavaScript where you need it, and you don't where you don't, right? So it's whatever level of comfort you have when building your application.
Yeah, exactly right. And obviously, at Microsoft, we know we're very OSS friendly. We're we're friendly with open source. Obviously, ML.NET is open source, right? Yep. That those kind of interoperability just makes sense. It's funny you say that about the application. If you go into the ML Workbench application, I went all the way onto the other extreme on that one. I will specifically challenge myself to say not to write a single line of JavaScript. And you can do that. And if you want to see a 100% C# Blazor application that looks, I think looks pretty decent with zero JavaScript code, obviously not, there's JavaScript inside Blazor, and now implicitly you have to do references, but that I had to write, that's custom JavaScript, that's you have the option. If you're parochial and you don't want a single line of JavaScript, you can do that. But obviously most applications are something like this, right? Where you have a mix and match of this stuff. So something for the future. I wasn't able to write some slides, but I figure I have a couple minutes. But one really cool scenario here is I'll give a call out to Lucene.net. So Lucene.net is an information retrieval engine. Allows you to do search, guided navigation, querying. You can think of it as a persistent store that you can do information retrieval all on top of. The current application that I demoed right now, it kind of does everything brute force. Loads a gigantic CSV file in the memory, or I read it and I put it in the memory, right? In reality, this application can be made about 10 times faster using Lucene. I was starting playing with it. Lucene.net, once again, supports .NET Standard, can run on the client. Now imagine being able to do machine learning on top of information retrieval on top of that, all on the client. So now you can do very cool things. And obviously that file that we're talking about, the questions around how big is it, 16.8 megabytes, well, that's going to shrink because the inverted index is very efficient in compressing data down into, I would imagine, 80% smaller than what it is. So
very, very cool. So we're running low on time here, so maybe we can get to some questions.
Absolutely.
So you were mentioning this pattern that you used to use with Silverlight of hot loading assemblies and things like that. And Skycolor here asks a question. Is there also lazy loading for any packages ELLs, not to load everything at once, or is everything bundled at once?
That's a good question. I probably should not be answering that question because I might say something. Let's take that offline because I'm not a .NET FPG and I don't want to say anything. I'm on the ML side. So let's get that question answered.
And the other thing that I will say, Skycolor X, and for any folks, I see there's a few Blazor questions. While we're showing Blazor, we are not Blazor experts, but there is the ASP.NET Core community stand-up, which takes place. So you can certainly ask those types of questions on there. We'll try to get to some of them, but again, none of us on here are Blazor experts.
Yep.
Let's see. So Sharafuddin, I guess this is kind of like a Blazor question as well, but one thing I still cannot understand, Blazor is only for SPA or single page applications. Is it for replacing JavaScript or any front-end frameworks? WASM downloading very heavy data, especially with DLLs, may have security issues. And I think we addressed some of these, but maybe we can clarify some of that.
Yeah, I would not table Blazor as a SPA application. That's what's being advertised. It is another service, another framework, another something, a tool in your tool belt. You can obviously Blazor is going to have its place where it makes sense for you to build applications. It's not going to be everything's going to be built on Blazor from now on, or all SPAs have to be built on Blazor. It is just an alternative. We have millions and millions and millions of .NET developers who are comfortable working with C# and .NET. Who, as you saw with machine learning.net, being able to do interesting things with it, not just do simple application, but infuse it with ML.NET in memory. This is the kind of stuff that these type of scenarios applications allows. I wouldn't pigeonhole Blazor into one specific thing, but those security scenarios, I definitely would check out some of the best practices. There we have a documentation on Blazor security. I would definitely check that out to make sure that whatever security concerns you have is addressed inside server side or WASM.
Yeah, that's I would, you put it quite nicely there. We have another question from Brushtail Technology Private Limited here. And we kind of addressed this, but it would be good to kind of go over that and maybe talk about, other scenarios, right? So what about data model size 100 megs? 100 megs downloaded in client side.
Yeah, so I haven't tested all the models, but I can see all these are all my ML.NET models I have brought down here. So it's not like I'm doing one little model and it's kind of working. It's there's a lot here. So the one thing that you do have to worry about when you do that kind of stuff is that obviously is how performance going to be. And the other thing is also Blazor WASM right now is currently if you're trying to do it in mobile or support devices that are much smaller that can still run this, you want to be careful in that because you will on some of the mobile browsers they will actually throw a stack trace if it's too large. I don't know where the limit is, but obviously having 100 megabyte models or 200 megabyte models, you might be pushing the capabilities of where Blazor WASM can go, if that makes sense. So I haven't tried anything, but obviously I have a bunch of models here. I'm not sure what the size of these are, but there's several of them, and they're they work.
Right. So even if one is in 100 megabytes, right? Perhaps the collection of them adds up to what's coming down to the client. But again, you're only using what you need when you're performing your probability calculations and such.
And then in this application, you saw how fast it was responsive. Every single one of these was loaded into memory, and every single one of these had a prediction engine associated with it, and it was still performing. Right? I wasn't context switching between each one at a time, but all of these were loaded in memory dynamically, and Blazor WASM was able to handle it. So.
Very cool.
So yep.
Yeah. All right. So I think that pretty much brings us to the top of the hour here. Thanks, Bart, for joining us. This was really, really interesting. I look forward to this space continue to, evolve, and for you folks in the chat and the community to build stuff with this and let us know, what works. If you get the training scenario working, we'd love to hear about it. Right. So yeah, thanks a lot. And we'll be back in 2 weeks. So until then, feel free to send us anything cool that you built. Send it to us. So we want to highlight you and promote you. And Bart, before we go, what's the best way to get in contact with you?
So I have pro and con of having a very unique name. So if you look me up, Bart Czernicki, and type in Microsoft or Bart Czernicki machine learning, you should be able to find me. And I have all the links posted, all the code is updated, all the presentation is all there. So if you find me on Twitter or on GitHub, you'll be able to find this stuff. I'm trying to make it as easy as possible for everybody to find it. And I am a resource. Feel free to contact me, reach out, and I'm glad to help. I work on the partner side, so if any partners are listening, big or small, we're glad to help out as well. So anything related to ML, AI, Blazor, .NET, we're excited to help.
Awesome. Thanks a lot again for joining us, and thank you all for tuning in. We'll see you in 2 weeks. Take care. Bye-bye.
Thank you, everybody.